Hello everyone, let's finish off this chapter by looking at statistics in the media. Lots of fun stuff. Let's look at a few pictures and graphs and talk about data in real life. This first one just here, got some channels on TV, got some shows and the viewerships of the audiences. So if you go to this website, you can actually look at it in more detail, but they use data all the time to figure out what shows are on TV. Are they successful? Are they not successful? Do they keep them on the air? So they actually closely monitor how many people watch shows on TV, done all the time. Here's another graph. So we're looking at different countries, looking at house prices by the different countries. Now we also actually, when you talk about house prices, you tend to talk about median house price and not mean, because obviously if you have a really, really big house price or a very small house price, the average would be inflated, but the median is just the middle, so that's not obviously affected by big scores. So normally house prices talk about the median house price. But again, go to this website, you can see this graph in more detail. Here's another graph. Got a few columns, different years comparing Sydney Ocean beaches, so different categories, obviously colours for each category. Lots of fun stuff. Again, here's a link here for the website. Let's keep going. Okay, we live in a world of 24-hour news, whether it is from papers, TV, internet, which often quote results from surveys. When survey data is used in the media, we need to consider a few things. Number one, where the news comes from and what sample statistics are based on, so the source, who supplied the information, the number of samples and what sample size was used, and the way which was collected and presented. So obviously really important that good sources are used, and this point here, number of samples, obviously you need to survey a big enough sample size to make your investigation worthwhile. I mean, if you're surveying people about, say, their favourite subject, and you ask 2 people, and they both say maths, and then you say 100% of people like maths, well, 2 people is a very narrow sample. So obviously, not too many. Obviously, you're not going to survey 5 million, but a middle ground between not too little and not too big to get good information for your results. Now, obviously, the way you get it, so Google surveys, in-person surveys, questionnaires, a lot of things you can use to get data. Use different types to obviously get relevant information. Obviously as well, this point here, the source. So, obviously you want to use reputable sources that obviously know what they're doing and getting correct information. Okay. Here's a funny little video, misleading graphs. Just go to YouTube, just click this link, and this guy here talks about obviously misleading graphs. You can see this one here goes up really fast. That's misleading. Watch this for information. If someone is trying to make a point, they may draw a graph which shows that point in the way they want. So it could happen in like a newspaper, for example, or a story making a certain point. This often happens in advertising. While the information presented may be correct, the way it is presented could mislead people to think that some effects are greater or smaller than they actually are. Here's a few pictures here demonstrating that. Obviously here we're comparing different social medias. You can see Facebook's number 1, but you can also see that the column is quite a bit bigger than the others and obviously stands out more, and also by saying first, you're kind of glorifying the fact that this is first versus the other ones. This one here, you can see it grows really quickly, but see how it starts at 2,000 and it goes up to 3,000. So this one versus this one, well, it's only 1,000 difference, yet the actual column is like 10 times higher. So that's obviously very misleading and making a point about how it goes up, but yeah, the scale is wonky. And compare this one to this one. You can see how this one starts at 0, has a more equal scale, but yeah, very, very different. Even though they say very similar information, like this and this is about 2,000, but the way when you don't start at 0 in this one and you have that difference, you can see it's very, very different in terms of the scale. You can actually manipulate the scale to really show data in a certain way, and sometimes advertising does that, comparing these two. Okay, here's a few more misleading graphs. So following are shown 3 ways of presenting the information in the table graphically. So we have X and Y. So X is 4,000 TVs, Y is 8,000 TVs. You can see that these are drawn very different ways. Obviously, this one is your column graph. So you've got X is 4,000, Y is 8,000, starts at 0. This one, they all start at 0 actually, but see how this one, they're now using area and size of the actual graphs themselves, even though this is only double this looks much more than double on this one. Same with this one as well. So obviously these are making the point that y is much bigger than it really is. Okay, the main causes of graphs being misleading are the scale on the vertical axis does not start at 0, like the previous slide. The scale on the vertical axis is irregular, so changing the scale. The scale on the vertical is missing, or the use of area or volume to create a false impression, which is what these two do. So even though this is only double this is much bigger, you can see in these ones, even though it is still 8,000. So be careful about actual shapes in graphs. Okay, here's a question. Question 1. What concerns could be raised about the following claim? The Daily Sun newspaper reports that it has an average issue readership of 1.385 million, and then its travel lift out has a readership of 1.455 million. So have a think, just drop down, what do you think, or what issues could arise from this, do you think? Okay, you may have seen already, but obviously these numbers aren't the same. Also, the travel bit is its own one, so its own lift out of its travel has more readership than the actual paper itself. So obviously its own stuff has been obviously increased. So we can say reporting about probably its own travel handout. Its own travel handout is biased. And we can also say that the travel handout, or lift out, travel handout has a higher readership than the newspaper itself. Okay, here's one more question. We're comparing the weights in kilograms of a large group of 18 to 20-year-olds attending university. Obviously, there's quite a few there. Okay, so the first question, how many students are in the group? Okay, so it's 9 by 10, which is 90. Not too difficult. Okay, part B, randomly select 4 groups of 10. Now 4 is going to take a while. I'm going to change this just to 1, just to make a point, because 4 will take forever. So 1 group of 10, and for each sample calculate, so the mean, median, and interquartile range. So basically, you'd pick 10 at random, and then of those 10, you'd find the mean, median, and interquartile range. So obviously recapping what we've done in the chapter. So for example, you may pick, just at random, just randomly picking a few numbers. Make sure it's 10. How many is that? I think it's 10. And then obviously of those 10, you'd find the mean, median, and interquartile range, like we've done in the whole chapter. So what I'd like you to do, please, is pick 10 numbers and find the mean, median, and interquartile range of those 10 numbers, please. Don't forget, to find the median and interquartile range, you've got to put them from lowest to highest as well. Now, if you're obviously struggling to pick 10 random numbers, you actually can use a calculator as a random number generator. All you need to know is find out what the lowest number is in here and what the highest number is. And you can actually put it into a random integer. So to do that, so let's write here. So ran integer. So you're going to press alpha, then you're going to press dot, and you're going to have this on the screen. Okay, in the bracket, you're going to put in the lowest number you can see, then comma, then the highest number, close the brackets, and then press equals. Press equals 10 times, and you'll get 10 numbers from the list. But just make sure that every number you get is actually in here, because there may not be every number. Is there 53, for example? There's no 53, it looks like. So you may want to, it might be better just to pick 10 at random rather than using this, but just put this here as a side note. So side note. And also to get comma, you got to press shift close bracket. Okay, so it's probably better actually pick 10 just at random, just literally just pick 10 and find the mean, median, interquartile range of those numbers, please. Okay, I'll just write the numbers out so we can see it in action. So 46, 49, 52, 57, 58, 60, 67, 70, 87, 100. Okay, there are 10 terms. Middle with a 5-point fifth term between 5 and 6 term. 1, 2, 3, 4, 5. So it's going to be in here. So between these two, there's my middle. Be right here. So that's Q2. Halfway between 58 and 60 is 59. Now lower middle from here and higher middle from those two. Lower middle is going to be, well, there's 5 numbers here. Middle is this one right here. So this is Q1, which is 52. And then upper middle, this one here is 70, which is Q3. Okay, so back to the questions. So mean, just add them all up and divide by 10. Very long process, but not that difficult. I'll just do it myself. Okay, I believe that's 64.6 if I've done it correctly. Part 2 median, that's just Q2, which is 59. And then part 3 interquartile range is just 70 minus 52, which is 18. And basically just to finish off the last two here, so you could use your results. So if your results are a good representative of the rest, they're accurate results. So basically what it's going at here, if you pick, like I said, these ones are completely at random, so it's fine, but if you picked just the 20s or just the 40s, for example, then that's not representative of all the data. And you'll find every time you pick 10 random samples, as long as it's a good sample, you should expect results that are quite similar to these. Okay, so that's a good way to estimate the entire population. Pick 10 at random, which represents this pretty well, and your answers will be quite accurate. Not exactly the same, but quite accurate. Now your work today is 611 from the textbook, so work on those. But before we get to that, I just want to show you one more thing on the next slide about your calculator with this chapter. Okay, just a little heading, stats on the calculator. Now just quick point to make, you can actually do interquartile range, medians, Q1, Q2, Q3 on the calculator. I'm going to show you how. Best way to do that is through an example. So let's just make up a few numbers. E.g., let's say we have 8, 15, 17, 23, 29, and say, 32. They're my numbers. Let's find the 5-figure summary. 5-figure summary. Remember, that's lowest, Q1, Q2, Q3, and the highest. All right, here's some cool calculator steps. So, calculator steps. Well, step 1, just make sure your calculator is cleared, just to make sure there's no numbers from before. So to clear it, so clear, shift 9 3 equals, shift 9 3 equals. That will clear your calculator, just to make sure there's no numbers in memory. Okay, let's follow these steps to put these numbers into the calculator to find out the 5-figure summary. Okay, I'm going to press mode. Then 2 for stat. Then press 1 for var, 1 var, means single variable. The bracket part is just what the calculator screen says, so mode 2, 1. Next step, you'll get a table. Put in each of these numbers and press equals after each one. So put numbers in, equals after each. Okay, next button is AC. Back to the main screen. Now don't worry, the numbers are still there. We're now going to press Shift, then 1. Notice there's a yellow stat above that 1 button. We're now going to press 5 for min-max. Now once on this screen, you now have 5 options. 1 is for min-x, 2 is for max-x, 3 is for Q1, 4 is for med, which is median, and 5 is for Q3. So they are the 5 parts of your 5-figure summary. So what you do now is press each of the 1, 2, 3, 4, 5 one at a time, press equals to get that answer, then navigate back to that same screen again to get each of the other 5 things. So separately, you can press, for example, say 1 equals, you get min-x is 8. That's a minimum score. Go back to that same screen again by pressing AC, then back to the same screen. Min-max, you might press 4 for med, which is median, which is 20. Okay, so you can actually use that screen to get each of the 5 things. So what I might just write, so let's just say, so shift, then 1, then min max, 5 options. So it's 5 options. So 1 min x, 2 max x, 3 q1, 4 median, and then 5 q3. So go to this screen 5 times, press equals for each of these, and you'll get your 5-figure summary of the data without having to do the calculations yourself. So yeah, so pretty cool stuff. Just write down the answers. So our 5-figure summary is going to be 8. Q1 is 15. So again, go to that screen 5 times. Q2, which is a median, which is 4. 4 on the screen, so 20. Then we want Q3, which is option 5. Notice it's not the correct order, actually, the actual options. And then the last one we want is max x, which is 2. That comes up as 32. Okay, so that's our 5-figure summary of the data. And one more really cool thing, actually. Notice how this was from lowest to highest. When putting this into the calculator, it actually does not have to be lowest to highest. Your calculator can do all the work for you. So even any order you put them in, it's fine. Your calculator will still do it correctly. That is so cool. Okay, see you in the next lesson.